Yeah, so this is a pretty exciting video because in this video we're going to be able to prove the chain rule, which is a pretty cool proof. Now, there are a few chain rule proofs out on YouTube, and most of them are correct, but not the one from that Academy. All right, let's get started here by first writing what we want to prove, which is the fact that the derivative of f of g of x is equal to, by chain rule, f prime of g of x times g prime of x. This is the result that we want to show, right? Okay, and to start, let's write the g prime of x by the limit definition of the derivative would have to equal this. And similarly, f prime of y, using the limit definition, would have to equal this. And we were bound to use a different letter from h when we're talking about f prime, and a different letter from x again when we talk about f prime. In other words, like we use x for g and h for g, but y for f and then k for f. Yeah? Okay. It's important to do so. All right, and then where to next? Well, next, let's let u equal this here. And so u is like this fella without this limit, right? And then minus g prime, right? Okay, notice then that as h goes to 0, u goes to 0. We're going to note this up here in a second. And the reason why as h goes to 0, u goes to 0 is because as h goes to 0, this turns into g prime. And so we'll have g prime minus g prime. And so u goes to 0 as h goes to 0. And if we similarly define v, but this time about f, then v would have to look like this, right? Okay, and this time as k goes to 0, v goes to 0. As I explained with u going to 0, it's a similar idea, right? As k goes to 0, this turns into f prime of y, and so v is going to equal f prime of y minus f prime of y, so v goes to 0 as k goes to 0. As I said, this is very important to note, so let's write it up there. All right. And then next, using this expression, let's solve for g of x plus h, and using this expression, let's solve for f of y plus k. And that's just simple algebra. Yeah? Okay, now, I'm not going to talk you through the algebra in detail, but let's talk about how you solve for g of x plus h in this equation. Well, you'd first add g prime of x to both sides. So on the left, you'd have u plus g prime of x. And then after that, you'd multiply by h on both sides and then add g of x to both sides, and you'll be able to isolate this fella, right? So if you do all that, then you'll find that g of x plus h is going to equal this here. And then similarly, solving for f of y plus k, we can see that f of y plus k is going to have to equal this here. Yeah? Okay, both of these expressions will be very useful in a second. And now, if we come back to the task at hand, which is to show this, then we could use the limit definition on f of g of x. And if we use the limit definition of the derivative on f of g of x, then we'd have to write that it would have to equal, limit is h goes to 0 of f of g of x plus h minus f of g of x all over h, right? Okay, but wait, we've worked on g of x plus h. It's right here, which is equal to this. So then we can substitute for this fella with this fella. And so let's do that in our next move, yeah? Okay. So let's do that here, yeah? Okay, now, next, what we want to do is notice that this here is in the form f of y plus k. It's that y is g of x, and then k is all of this stuff, right? But this here is in the form f of y plus k, right? Okay, let's note that, and as I said, let's spell it out, which is that it's in that form because g of x is y, right? And then u plus g prime of x all times by h is equal to k, right? This is k, and this is y, right? Okay, now notice something very, very important, just as important as what we noted up here, which is that as h goes to 0, k goes to 0. Because when h goes to 0, this whole thing is going to go to 0, and therefore k is going to go to 0. Right? Okay, cool. So as h goes to 0, k is going to go to 0. But wait, we said as k goes to 0, v goes to 0. So by transitivity, that means as h goes to 0, v goes to 0. Yeah? Okay, so that's this, right? Okay. And next, we're gonna use the fact that we know that f of y plus k is equal to f of y plus this stuff to figure out what this is going to equal, right? Like this is, as I said, in the form f of y plus k, right? So if we use what we know about f of y plus k, in other words, use this right-hand side, we can write this fella, right? F of all this, we can write it first I'm spelling out that this here using again this here will turn into this, right? And so you guess what we're gonna do next. We're gonna take this, which is equal to this, right, and replace this whole thing with this giant big thing. All right, okay. And so then that means that our difference quotient here, right, is going to be it's going to be this here. Yeah, okay. And notice, by the way, if you haven't already done so, that I abandoned the limit for a second. I've been working on just this quotient. We're gonna call back the limit as h goes to 0. Let's just, keep working on this quotient, which started here, turned into that, and now it turns into this through all the reasoning that I already explained. Yeah, now notice that here we can cancel f of g of x here with the minus f of g of x here. So if we do that, then we can condense the difference quotient to this. And now notice that h here and h here can be crossed out. So we cross out the h here and the h there, and see that our difference quotient this is going to turn into, well, I'm gonna need space, so boom. So I'm gonna pick up where I left off right here. That, right, is going to equal, I've already talked about canceling the h's, so if we do that, it's going to equal this, and then that's where all this important note is gonna come in. Well, remember, we said that we're gonna have to write lim as h goes to 0 in front of this, meaning we're gonna have to write lim as h goes to 0 in front of this, which means we have to write lim as h goes to 0 in front of this. Alright, yes, I'm a little too excited and eager about this. Now, as h goes to 0, we already said, as h goes to 0, v goes to 0. So v will go to 0. And as h goes to 0, as we said at the very beginning of these notes, as h goes to 0, u goes to 0. So when we put a limit as h goes to 0 in front of this, in other words, when we put a limit as h goes to 0 in front of this, the v and the u will disappear, giving us the result that we want. Yeah? I'm just like summarizing stuff I've already said. Yeah, all the important stuff, and we're done. Isn't this cool? I thought so. Alright, I hope you enjoyed it as much as I did, and keep watching. Take care.